Okay. Hope my screen is visible to all of you. Good evening, everyone. Just a quick recap what we have covered till last day's session. It was entire SQL stuffs we have covered in last week and the extra 2 days. So SQL, just a quick recap, what is SQL? And I mean, at the beginning of the session, we learned database, and there we learned there are two kind of databases we can represent over there for data analysis part. So, relational database and non-relational database. So we worked on top of relational database and how to go ahead with the analysis part. What are the languages? What are the basics codes to learn the operation on top of relational database that is been covered in SQL part. Okay, SQL is structured query language. So over there we have learned how the database means. I mean the database basic unit is called table. So how the table can be created, how multiple tables, how the relationship can be set between multiple tables and all. So, in SQL chapter, those 5 days we have covered the languages to create the tables, to alter the tables, to have the visualization or data manipulation on top of the tables, to have the select query, the aggregation function, particular sorting operation, all the operations we have covered through DQL, that is um, data query language. And after that, in the end of the stuff, you also learned some other modules on top of view, store procedures, as well as some, transaction control languages as well. So that is the usefulness of SQL. Hopefully, there is no stuck point for SQL. Actually, we have also gone through one particular example on top of all the SQL operations that we have covered over there. The exercise we have covered on last working day. So I hope there is no issue for understanding. If there is any stuck point on top of SQL, kindly ask me over here. And just trying to say that today onwards it should be a new topic, business intelligence. I'll be covering for rest of the 2 days. Today and tomorrow. After that, Python chapter should be started. Business intelligence is the overview of the thing. Why the data engineers are required in those kind of business. Nowadays. So this is the usefulness of business intelligence. Why we are using SQL? Why you are using Python and all stuffs from the data engineering perspective. The overall idea we can get from business intelligence chapter. So that thing will be covering by today and tomorrow, and after that we'll be starting Python chapters. Okay, it should be starting from Friday. So this is the course plan. Any stuck point or any questions till now? Nothing. Okay, hopefully it's fine for everyone. So let's get started with the business intelligence. Okay, let me maximize the screen. Today and tomorrow it's not very much technical thing we'll be covering for business intelligence, rather we can say it's the basic thing for why data engineers are here for doing their jobs. Okay. So, what is business intelligence and how data engineers are been involved over here? That is the main requirement to learn it. Going to the topic. Okay. So, over there, as per the pictorial diagram, you can see, a particular shopping mall is has multiple sales outlet. Okay. So you can see in the left hand side pictorial diagram, those are the different sales outlet, and we have our BI application. BI means business intelligence application. In this application, we are collecting the sales information for each of the outlet. Okay. We're collecting it from, over here. Now data engineers are working over here. They're manipulating the data. They're transferring the data from this meaningless transactional data to meaningful data over here in BI application. And they are representing the data such a way that those kind of answers can be created by maybe graphical orientation, by maybe some SQL, something over there, so that the business owner can have their answer from this meaningful data. Okay, just like sales in previous quarter, revenue growth in last 5 years, best selling product in each of the season. So this is just three questions. There are a lot of questions to get business insight. We can directly see from the output of BI application, and the business owner can take easy decision. They always try to have their revenue that should be bigger than that of the previous day. Okay, they has the motto to have less loss amount for each of the day. Okay, that's why they can forecast the thing by the BI application. They can check how they can improve in next quarter. Okay, so BI application will help them for forecasting their business as well. Just a quick example, I think I have covered it earlier. Suppose I'm owning that particular shopping mall over there, and my shopping mall is have another plan to produce a product. Okay, I'm producing a product, but some of the outlet the product sale is very less. So we can see from this meaningful data that this particular product is, I mean, we are having loss only for this product. So this kind of quick search can be done by this BI application. If we do not have BI application, we cannot search for it quickly because there are lakhs of transaction per day. Okay, so we just have to think of the main culprit of the product. Then we have to decrease the production of the product. Maybe for that particular outlet, the production is, I mean, the selling of that particular product is very less. Maybe the same product is having higher selling rate in a particular outlet as well. Then we have to take the business strategy such a way that the product should not come to this outlet, but it should be coming to the popular outlet with more numbers or with more transactions or just like this kind of strategy actually that should be helping us to grow our business. So to check the meaningful data to take the decision properly, that will help us for the business growth and all. So, I mean, data engineers are playing this role in BI application itself. They are gathering the sales information, the raw data, which is not meaningful one. They're collecting it. Then BI users, they are transferring the data such a way that it can be a meaningful one. Okay. So just like we have understand the first or second day's class, there was normalized data. Okay, so BI engineers can help to set normalized data of each of the table. Okay, so when we are collecting the data, sales information, it was not normalized in nature at the beginning, but we are converting into normalized data and we are storing it to data warehouse. I'll be coming to this concept in later slides. And data warehouse, from the data warehouse, it can be easily shown to the end user what is the I mean, those kind of KPIs says or how we can forecast the business. Okay. Just like a quick example over here, OLTP system. OLTP is a transactional system. Okay. I'll be coming what is OLTP, what is OLAP and all. So just as of now, OLTP is collecting the source information from the source system by ETL tool. ETL is a tool where we are loading the data to data warehouse. Okay, in data warehouse, we are loading it in a meaningful way. Okay, so ETL, it's extract, transform, load. The tool's abbreviation is called extract, transform, extracting from the source OLTP system, transformation it, I mean, do the proper transformation, whatever is required for the business purpose. Maybe it's a USD amount is written over there in sales, but we are from European client. They need their local amount to be recorded over there. Okay, so conversion means we can convert the currency of the of each of the sales of the product. So this kind of conversion, okay, it's required. And load, ETL, extract, transform, load is required in the data warehouse. So whatever table we are receiving at the source side, that we can transform it meaningful way and store it in data warehouse by ETL tool. Now this data warehouse is having the meaningful data. This data can be used for reporting purpose. Reporting means we can create charts, graphs, lots of and variation of charts we can create. And those charts are useful for the decision owner or the end user to take the steps for the strategy planning. Okay, business strategy planning. On the very next day or on the same day, they can implement the same strategy. Suppose they are checking some loss is there for particular strategy. So it's a closed process. They can quickly update the thing at the source system, or they have taken some strategy at the source system. So in the next day itself, it has been modified over here. The business improvement has been applied at the source system, or a particular strategy has been implemented over there. So OLTP will be having the new strategy now. So after the very next, if we check the reporting tool again, then we can see the graph is much more the expected one, what business strategies they are planning with. Okay, so this is entire loop with a closed system, how the BI system works. It's called BI cycle, business intelligence cycle. Any doubt from anyone? This is the overall picture of the business intelligence and how the data engineers are involving over here. They are working in this portion. They're collecting the data from the source system. They're transforming the data by ETL tool and loading it to data warehouse. Rather, the visualization tool, some data engineers are working in the visualization tool only, just like Tableau. Uh, just there are Click Sense, Click View. Those are the tools, reporting tools. So on top of data warehouse tables, they're creating various charts and graphs, and they're presenting the data to decision owner. Okay, so those are the stuffs can be covered by data engineers. Okay, any doubt from anyone? If you have any doubt, kindly tell me, or any stuck point. Today's session is very much simple, as well as it should be non-technical as well. But the thing to be learned to, that thing is very important to be learned. Why we are doing this kind of SQL operation? Why will be learning Python? What are the importance from our role in the business side? Okay, why actually data engineering is required in each of the business? Okay, suppose I am owning a particular project. So maybe Java is required, SAP is required. Then why the BI is required? This is the purpose to forecast their business, to check how to grow their business. Okay, it's a forecasting one. So this is the reason for, each of the business strategy. I mean, uh, the big business owners and just like this, they are owning this kind of thing. Okay, even data scientists, they are also working on top of data warehouse. They can write queries, or they can write Python codes pointing to this data warehouse and create the charts and graphs on top of that. Okay, and they can present the same thing to decision owners again to take the correct decision. Okay, or insight of the data, they can have the probability what should be appearing for tomorrow if we are going in this way. So this kind of forecasting thing can be easily done. The business can see their own future. Okay, so how much important BI is. Moving to the next slide. Okay, so we are learning over here OLTP. So what is OLTP and what is OLAP? OLAP. OLTP is this kind of thing, and OLAP is we are storing the data in the data warehouse, that is called OLAP. OLAP. Okay, OLTP is an online transaction processing system. So whatever source data we are receiving from the source system, just like we can tell OLTP systems are the class of the system that can manage, facilitate, and support operational or transaction oriented application. So daily basis transactions, just like bank transactions, any sales transaction in the shopping mall that I told you, railway booking system or cancellations as well. The system that manage and support these activities are OLTP system. So daily basis transaction is being stored in OLTP system. So it's the raw data rather we can say. Okay. And OLTP is the particular storage. It's called online analytical processing. So we are creating it a meaningful way. We means the data engineers are taking data from OLTP source system. By ETL tool, they are transforming the data and loading it to the same thing in data warehouse. And that particular data is called OLAP, Online Analytical Processing System. Okay. And why it's called OLAP? On top of that meaningful data, we can do analytical operation. Just like the same thing we have learned in SQL things, we can do lots of analytical steps on top of that, and it can be easily determined. Those analytical functions can be very much helpful. And just like data scientists, they can take their work quickly. What should be the output? What should be the outcomes and all? So those are called analytical processing. Data warehouse, we can tell it in such a way, OLAP system. Okay, we can do complex query on top of that and all. Okay, moving to the next slide. I think you have understand what is OLTP and OLAP. Okay, now a quick introduction with the on top of the decision support system. Maybe they are, we can tell them as the end users as well. So they can take easy decision to check on the output of the reporting tool, which is pointing to the data warehouse, or rather we can say OLAP system. Decision support system, they can take easy decision on top of their business. So what is sales distribution per region wise? How much profit does a particular product contribute? So this kind of questions. You can see there are lots of questions. Those are called KPI as well. We'll be learning what is KPI maybe in tomorrow's session. So this kind of business related questions can be answered by our BI tool. And the decision support system, they can take decision what to do in the next strategy planning for the business. Okay, and they can take or they can approve their decision into the business. So this is called decision support system. Moving to the next slide. Okay, so just a graphical representation. I was telling you on top of data warehouse how the charts and graphs are being prepared. I just give you the example, just like this is our OLAP data or data warehouse data. On top of that thing, you can see visualization engineer can create those kind of charts and graphs. So on checking on that particular thing, it's how much helpful for the decision owner or decision maker to take decision for the next quarter's strategy or just like this. Okay, by this by this database or by this data, we cannot easily take the decision, but we can take easy decisions on top of these graphs. So what is the, growth over there? We can check. There are various types of charts and graphs, just like there are pie charts. Those are called bar plot. Okay, there are scatter plot. There, heat map is there. Box plot is there. Each of the business strategy or each of the business scenario can be represented by each of the graphs and charts. So on top of the data warehouse, they can create those things, and business owner can or the end user can check those graphs to take their decision. This is the entire flow. Just I'm trying to say over here. Okay. So it's a simple thing. If we do not have the decision support system, we can or the business can face this kind of scenario. Data is spread across the organization, but we cannot take the easy decision, or the decision owner cannot take the easy decision. Okay, so it should be really hard to get what is the culprit, what is the product that is, we are having the loss of that particular quarter. So this kind of stuff, it should take really, long time to take the decision or really long time to identify the cause and all. Okay, so low productivity should be there as well. Reusability of the reports, that cannot be appeared if we do not have this DSS and all. So it was required for our business intelligence purpose. Okay, now moving to the concept at this topic, at OLAP topic from the source system. we are coming to this concentrating on top of this topic. So just a quick flow chart and diagram. I just try to present over here. So transaction level data, which are coming from the source system itself. I mean, the sources, maybe it's coming from the data entry operator, maybe it's been done, maybe .NET framework, some input has been inserted, maybe SAP framework, it's having from the source system, and it's coming to operational database that is called OLTP. Okay, but it's not meaningful in nature. So we are receiving the data in this way in operational database, and we by ETL tool, this is called ETL tool. By the ETL tool, we are processing the data, or rather we can say processing the tables into meaningful tables over here in data warehouse, and we're storing all the tables in data warehouse. Okay, and from I mean on top of data warehouse, the visualization engineer, they can visualization engineers can also be included in data engineers itself. Okay, so those kind of visualization tool, they are helping on top of the data warehouse. They are creating the reports, charts, graphs, and our decision owner or manager, whatever we can say, they can check the report to take the decision. Okay, so just to concentrate on that one, this is called data warehouse, and our ETL tool is loading from OLTP system to data warehouse tables. Okay, so data warehouse can be a database, just like whatever we have, checked over there. Maybe it's MySQL database. Over there, we can store multiple tables from loading the data from the source system itself. But ETL tool will be helping the rest of the stuffs. Now, what Python will be playing over here? So Python is playing the key role for a ETL tool. There are lots of ETL tools are available in the market. Even in parallel of this ETL tool, nowadays, open source languages are also being used to create lots of frameworks. So it should be working as a ETL tool there. And those kind of ETL tool can extract the source systems data, they can transform it, and they can load it into data warehouse. Okay. Moving to the next slide. What is data warehouse, and what should be the property of the data warehouse? Just like the concept is this, it should be some subject oriented. A particular subject topic should be there for the data warehouse. We cannot implement multiple subject areas into the single data warehouse. Then we need to create another data warehouse for the same. Okay. It should be integrated. The data within the data warehouse should be integrated in nature. We should be maintaining particular data model there to store the data warehouse. Okay. The data should be time variant in nature. So we can have a time travel. Maybe it should be storing the historical information as well. Maybe we need to check the 5 years back data, and data warehouse should be store that particular data for us to have this. The previous historical business data and all, everything should be present, and that should be required for our future growth as well. Just to handle some operation, whatever we have learned in the history. So that's why the revenue growth or the rate of the growth is required if we have the historical information. That's why data warehouse should be time variant in nature. It is non-volatile. As you know, it should be always up, and the business owner or anyone can be working on top of this data warehouse. So it should be non-volatile in nature. It should not be erased. Okay. There might be some strategy or technology that we can take daily basis backup, so that if one data warehouse is down, we have the other thing to support it. Okay. If one data center is down, we have the other data centers to support the same data. So we need to choose such a database such a way that we can retrieve the data. If the data is lost, we can have a time travel and retrieve it from the past scenarios. So it should be non-volatile in nature. So it's a quick architecture diagram. I just take it from portal. So just like the same thing, with some more details over there, we are checking. Those are various source system, just like FS1, FS2. Those are um, um, ANF database source system. We can rather say those are OLTP source system always. By mainframe, we are receiving the data from the transaction point of view. Just like if we are checking in the Indian railway system, so if we are just going to the ticket booking part, to the ticket counter, okay. So I believe, yeah, they are using mainframe technology there. So they are directly putting the information and it's coming to this source table itself, okay. And those are called OLTP, transactional processing system over here, okay. Now the operation of extraction process to data warehouse, it's coming directly from here. This is the works of the data engineers. First of all, we cannot directly store the data in data warehouse. There's various ways we have to do the same thing. So first of all, extraction, that I told you, extract. By taking extraction directly, we cannot put the data into data warehouse. We have to put this thing in a staging area. Okay, staging area is also a database, but we can stage all the information from the source system to a single stage area. There may be multiple source system. Maybe there are flat files. Maybe there are different kind of databases working as a source system. Okay, but we are pulling all the things in a single staging area, single stage database. Okay, and it is also been done a ETL tool. So after receiving the thing in the stage area, we can clean the data. There should be lots of duplicates data at the source system. There may be lots of erroneous thing. Maybe typo is there. Maybe lots of white spaces are there. Maybe there are the things are there which is not meaningful in nature. We need to clean the data. We have to transform the data. Okay, just like I told you a few days ago, we should be having correct date format so that we can analyze the data over here. But the date format has been inserted such a way from each of the system. Maybe some date format has been inserted from here, which can be treated over here as a character. So date operation we cannot do on top of in data warehouse. So you have to put a unique way for putting the date conversion for each of the source system over here as well in transformation. Okay, then we can do the aggregation summarization as well, just like stores group by operation. Okay, and we can store the result into data warehouse rather in data mart as well. What is data mart and ODS? I'll be coming to this point quickly. ODS is intermediate database as well. It's not required for all of the business purpose, but sometimes we use ODS. ODS is for real time data processing system. Okay, so it's very first on source to target, and real time means whatever is happening at the source system, we can quickly check in ODS, operational data store. Okay, but all the three things are being available for OLAP analysis. Analytical processing of the things, because all the three, the ODS, data warehouse, or DM means data mart. So all the three things are being used for data analytical purpose. We can, on top of that, we can put the select query to get our desired result. Okay, or the business owner can take the desired result, or the visualization can work on top of data. On top of those tables, they can create the charts and graphs. Okay, or rather we can say on top of the data warehouse data marts, uh, data scientist can check the data and they can grab the insights of that particular data. Okay, so that's how those are important in nature. So just a quick introduction on ODS and data marts. ODS is called operational data store. That I told you, it's a real time data from source system. What is there at the source system and target? It's very much faster to load it from source to target. Real time means maybe it should be refreshed with very frequent. What is there in source? We can quickly check the thing at the target. Target means ODS. Okay. So just to solve day-to-day problems, we can use ODS, but it's not the uh, urgent, or I mean every business solution they can use ODS, they cannot, based on their solution strategy. Okay, but the data warehouse is the compulsory one. It should be there for each of the business owners. I mean data warehouse as well as data marts. So data mart is just like a miniature of data warehouse. We are storing the data in data warehouse. Then based on each of the sub area. Okay, suppose I'm booking, or I'm collecting the information of uh, each of the sales related data, or maybe each of the banking related information. Okay, in data warehouse, we have one banking related information for a particular bank only. And data mart we can create from data warehouse, that the credit related information can be goes to one data mart. The debit related information should be going to one data mart. The offerings related information can be go to another data mart. So all the data warehouse things, just like it's a subset of that data warehouse. It's a miniature of data warehouse. That's the thing for data mart. Okay. Example is been given over here. Data warehouse contains from multiple subject areas, but the subject areas is not different that I told you. But data mart is a simple form of the data warehouse that is focused on a single subject area, such as sales. For sales, there should be one data mart. For finance, there should be one data mart. Marketing purpose, we should be having one data mart. Okay, just like it's a miniature of data warehouse. That thing we can say over here. Based on the functional area, we are storing the data over there. So that is the concept of data mart. Okay. Another flowchart, I just tried to help you to understand the thing. Is the source system again from the insurance thing. Even from the insurance is another large sector where we are storing the data in the transactional system. Okay, so there are different kind of. Okay, I remove the medium, I mean the intermediate process. So moving to the stage area, then moving to the data warehouse, then we are pushing it to data mart. Rather, we are just giving it a pipeline format. So property insurance data, we are putting it property data mart just to have the concept of data mart. Automobile related insurance data, it's having automobile data mart. Commercial insurance data, we are putting in commercial data mart. Okay. Then we are creating the report. It's in OLAP storage. We are creating the report means charts and graphs on top of these data marts, and that can be easily visible to the DSS to check the report. Okay. Okay. Now a quick introduction. So we are storing all the information in data mart or data warehouse in tabular format. Okay. But the table should be in two types over there. Okay. And we are creating the relational database at the target system. What is relational database? We have already learned. What is table? We have already learned. But the tables are having two kind of property. Okay. So first tables which are storing the fact data. What is fact? I'm coming to this slide. The tables which are storing fact related information. This is called fact table. The tables which are loading dimension related information, those are called dimension table. Okay, so that way we are creating the meaningful data. What are facts? What are dimension? And in OLAP system, we can create the data modeling. Data modeling means the relationship between all the tables, the fact tables and dimension tables. That will be covering tomorrow's session. But what is fact table and what is dimension table? Till that topic we will be covering by today. Okay. So what is fact? First of all, what is fact? If we question to the data of how much or how many, maybe the answer should be in numerical in nature. Okay. So those information is called fact. So fact should be measures. Just like what should be the answer? What can be, I mean, declared by fact. It should be revenue. It can be cost, number of accounts. All those things are numerical in nature. Okay. So numeric data, we can rather say it's fact. Not all the cases numeric data can be fact. Some cases numeric data can be dimension as well. That thing will be coming to the point details maybe by tomorrow's session. But fact generally can be the numerical data. Okay. So those are called fact, and all those fact can be stored in a particular table that is called fact table. Okay. So this is called a fact table. Sales table is a fact table. Billing table is a fact table. We can see now in the fact table, you can see the red color highlighted column. Okay. There is a sales table we have created at the data warehouse. The red highlighted columns are fact information. You can read out it. Sales. It can be quantity sold. It can be price. It can be discount. So the data types are also mentioned over there. Sales can be floating type. Quantity sold can be integer. Price can be float type. Discount can be float type. But apart from this fact data, we are having some other information as well. Those are primary key of the table as well as foreign key of the other table. Okay. So primary key, foreign key concept is already clear to us. We have learned this at the second day session. Okay. So fact table can contains the fact data as well as the foreign keys. Okay. Why foreign keys is required? Because the joining purpose, we will be using the relational database over here, where fact is the main table. It should be storing all the keys. It should be primary key of the same table as well as foreign key of the different table. Those are dimension table, different dimension table rather we can say. Store is a dimension, product is a dimension. So there should be stored table and product table as well. To join between these two table, we are using this foreign key. Store key is the primary key of the store table. Product key is the primary key of the product table. But it is the foreign key over here. So we can set relationship between by this foreign keys. Okay. Same things for billing as well. You can see those are all the highlighted one is the main facts, main fact data. And apart from that, to set up relationship between multiple dimension table, we are using the foreign keys. Okay, just like customer key. Customer key is for setting up relation for customer table. There is customer dimension table. Customer key is the primary key of that customer dimension, and we are setting relationship there. Service line key, rate plan key, those are all the key. Now coming to the dimension, what is dimension? Dimension is the thing where we can get answer, we can get the answers if we questions who, what, when, where in the data. If we question this kind of questions, this kind of keyword who, what, whatever answer I'll be receiving, that is the dimensions. Okay. And dimensions is just like a quick example. Maybe store is a dimension. Store table is a dimension table. Product table is a dimension table. Over there, we can store the information such a way. Store, I mean, there should be a primary key and multiple dimension data. Store name, their street address, the city, state, region, country. For product, the product key is the primary key. Apart from that, product ID, product name, product group, the brand, department. So product related information should be mentioned over there. Now, how we are setting up relationship, that fact thing should be helping us. In the fact table, we have found that product key is also present there as the foreign key. So we are setting up relationship between this primary key and foreign key to grab data from dimension and set relationship between fact and dimension. So that is been done by data modeling. Okay, data modeling stuffs we'll be learning in tomorrow's session with more details. So I think this is the last topic for today. How to create fact and dimension table from the meaningless data of OLTP system. Okay, so the entire thing can be done by the ETL tool itself, extract, transform, load, and the SQL query we are using over there. Okay, SQL is the basic thing, whatever we have learned to create the table, to alter the table, to push the data inside the table, to visualize the data, whether the data is perfect or not. That can be done in the SQL. And by storing the information from the source to target, the data flow and everything can be covered by ETL. So we'll be learning Python as a ETL tool there. Okay. And what is fact and what is dimension? This is very much important concept. Maybe that can be also asked in your interviews as well. And this is the thing, what is fact and dimension. And this is the way we are storing the meaningful data, either in fact or either in dimension. And we have to choose proper primary key and foreign key such a way that so that we can set up the relationship between them. Okay. Okay. So any questions from anyone till now, whatever we have learned? Anything? Any doubt? This is totally purely, a high level logic. What is happening inside the business intelligence process? Okay. Maybe the one who are doing MBAs, they are the business associate or just like business analyst. They can know all the things from the top view of this design and all. But the data engineer should be working to make it the fruitful one, to create the data and to create the data to be stored in data warehouse and the data mart in dimension and fact. Okay. Okay. Hopefully there is no issue or no stuck point from your side. So let's connect tomorrow to work with this fact and dimension and how to create the data modeling. Okay. So that's all for today's session. Let's connect for tomorrow to have the more idea on top of that. Okay. Thanks. Thanks everyone. Bye bye. Hello.